Okay, guys, here we go. So, continuing on the theme of serverless, please welcome Bret McGowen, who is a developer advocate for serverless at Google. Serverless for apps, machine learning, and big data. Bret, the stage is yours.
All right, thank you so much. I'm very happy to be here. My name is Bret McGowen. I am on the serverless team at Google, and I'm going to talk to you a little bit about kind of the breadth of things that you can do with serverless, some things that we're doing at Google, and hopefully some tools you can use when building your applications. I live in New York City right now, but I do have to say I'm from Texas. I'm too far away. There we go. Much better. So howdy and welcome. You can follow me on there on Twitter at @BretMCG. So just a quick, you have to do this every time you talk about serverless. Let me just take 3 slides and explain what is serverless. So the idea behind serverless is normally you build your application, and once you scale it beyond 1 machine, to 2 machines, to 3, to 4, to 5, as your application grows and gets more popular, you end up having to create an infrastructure architecture that looks like this. So maybe all of your requests go into some kind of queue, so it gives you time to scale up your backend. A lot of this distracts from your core value, which is what are you delivering from a business perspective or for your user's perspective that's useful and interesting. And rarely is infrastructure that. So it oftentimes starts out with a nice infrastructure diagram that looks like this, and then quickly turns into something that looks like this. And then if you're me, this is my last startup, it ends up looking like this. So we want to strip all that away with serverless. We just want you to worry about code. Let your cloud provider, let your functions as a service provider worry about kind of all the munging and scaling and networking and load balancing that's required to do that. So when I talk about serverless today, I'm talking about 3 core principles. So the core principle of invisible infrastructure. You don't know necessarily how many copies of your code are running, how many instances are there, how many nodes are there. You're not worrying about installing operating system updates or managing networking or attaching disks to your virtual server. And then also automatic scaling. So as traffic goes up, your app goes up, your infrastructure goes up, and as traffic goes down, it goes down. And this is really cool and really key to serverless is the idea of you only pay for what you use. So if your code runs for 1 second in a month, you pay for 1 second. If it doesn't run at all, you pay nothing. So when I talk about serverless today, these are the kind of the 3 fundamental principles that I'm talking about. And I like to break serverless into 2 categories. And when most people talk about serverless, they talk about functions as a service. So this is when you take the actual infrastructure that's running your app. This is your servers, this is your networking appliances, this is your disk array, and it abstracts it away so you don't have to worry about it. But there's another category of serverless called backend as a service, which takes your application components and exposes those to you as a service. So things like authentication. Things like email. So think about OAuth for a second. Actually, let's not think about OAuth. It's horrible. But when you do OAuth, there are things like you have to have an OAuth server, you have to stand it up, you have to handle the handshake, passing credentials around. It would be really nice if you could just outsource all of that to some provider and let them take care of you. Similarly, something like email. You could create an SMTP server, you could create an array of POP servers, you could work with your ISP to get all your IP addresses whitelisted, build up a reputation so not all of your email gets sent to spam, yada, yada, yada. Or you can just sign up for something like Mailgun or SendGrid or these services that just do it for you, right? Like if they've made that their value proposition. So you don't have to worry about managing a fleet of email servers. Let someone else worry about that. So it's the second category that I'm going to focus mostly on today. So the first, serverless for apps. So these are mobile apps, web apps, maybe embedded devices. And most specifically, I'm going to be talking about a tool called Firebase. Is anyone using Firebase? Oh, quite a few. All right, who's heard of Firebase? All right, a bunch. So if you don't know, Firebase is an SDK. It's cross-platform. It's for iOS, for Android. There's a Node.js client. There's a web client. There is a C++ client for embedded devices. There is a Unity plugin if you're building games on the Unity platform, and also has a REST API, so you can just talk to it over HTTP. And it does a bunch of things. So let me just take a second here and explain what is Google, what is Firebase, what is Google Cloud. So Firebase is when you're building mobile applications or web applications. You can use the Firebase set of tools. And it's backed by Google Cloud. So Google Cloud, when you think of a typical cloud provider, it has your virtual machines, it has your functions as a service, it has your big databases, all that good stuff. But when you're actually needing tools to build a specific application, Firebase has a whole bunch of things. Everything from virtual Android devices in the cloud to showing ads for monetization to authentication, databases, and on and on and on. But Firebase is backed by Google Cloud. So for example, when you upload a file using Firebase, it goes into what we call Firebase storage, but it's actually backed by cloud storage on Google Cloud and kind of all the enterprise level security and reliability and redundancy that you can expect from a cloud provider. So first I want to talk about the Firebase Realtime Database. If you've seen Firebase demoed before or heard about it, you've definitely seen a demo of the Realtime Database. But briefly, if you aren't familiar, it is a fully managed NoSQL JSON database. It runs in the cloud. And it has a couple of things that it does differently. One is that it does this real-time synchronization automatically and for free. And I'll show you a demo of that in a second. The other thing that it does is, and this kind of scared the hell out of me when I first heard about it, is your clients talk directly to the database. We're sort of used to these in-tier architectures where you have your application that talks to, say, an HTTP API, and then your API, you're running some back-end server code, and that's actually talking to the database. And then maybe relaying changes through some WebSockets or whatever. Well, Firebase kind of turns that on its head, and your clients actually talk directly to the database. And you can set up sort of some code to run in the back end, which I will also demo. But it's just kind of a paradigm shift, and it makes building applications really, really fast and really, really fun. Once you kind of get over that initial hurdle, there's a whole set of security around that, which I'm not going to get into on stage because we don't have time. We have a bunch of stuff to talk about. But just so you know, security is real, it is handled, and people are running enterprise production grade workloads on this. So now that's being said, let me pop over into a demo. So I have this beautiful app here called Firebase Demo. I named it myself. Oh, that's good. And it's already broken. OK, awesome. Please hold. Did I lose my connectivity? You can tell I wrote this because it's already broken. Come on. Everyone just get off the Wi-Fi. Just kidding. If I don't have internet connectivity, this is going to be a quick talk because most of my stuff is demo and needs cloud. Come on, this looks promising. Oh, no. Let's just see. You know how it works when you're sitting over there and then you get up here and it doesn't? All right. I don't have anything. Let's try. I'm on tethered. That looks good. Ooh, this looks promising. OK. Is there another one? All right, please hold for dramatic unveiling of. Was it? All right, let's see if this works. All right, thank you. Thank you. All right. There we go. All right, so back to the demo. So I have this beautiful web app that I've built on the left, and I have the Firebase database on the right. So what I want to do is I want to have my app automatically update some text here whenever I put a message into the database. So here I'm going to say message, like hello, Voxxed Days, or just, OK, that works too. And as soon as it changes, I want this to show up on my web page. So let's take a look at the source code. Right now, it is literally just a static HTML file. There's no JavaScript, there's no backend, there's no server, there's nothing. It's literally a .html file sitting on my desktop. But I've done a couple of things. I've included the Firebase SDK here. And then I have this H1 called title. So this is what I want to change. I actually pre-canned some JavaScript here. So once the DOM is loaded, I'm going to do some Firebase stuff. So once the DOM is loaded, I'm going to get a reference to the Firebase database. So this Firebase object comes from the include up here. And now I'm going to say, whenever any value changes on /message. So /message was when I had entered this node here. Whenever that value changes at all, run this function. So if you think about sort of the mental model, whenever a database value changes in the cloud, run this client function. Okay, so think about how much infrastructure that would normally take. You'd have to have your client that's doing WebSockets or maybe long polling and saying, hey, has something changed? Has something changed? Has something changed? So what I'm going to do with just a few lines of code is do all of that. So in fact, literally just 4 lines of code. So whenever this value changes, go get this ID title, this h1, and then set the inner text to the value. So let's try, let me refresh this. Yay. And awesome. Is this not, do I not have internet activity? Oh, you know what? I think my web server died. Sure did. All right, let's do this again. Live demos. You can tell it's real because it keeps breaking. I think when I lost internet connectivity, my local web server died. So let's try it one more time. Let me refresh. All right. And I will say message. Howdy, y'all. So I'm from Texas. And then instantly updates. So literally with just those few lines of code, a client-side database event is triggering, a server-side database event is triggering in the client. So let's actually push this live. So I'm going to do a Firebase, deploy only hosting. Firebase has kind of this included CDN. It's replicated across a bunch of regions globally. And it automatically will give us this URL. And so raccoonhouse.firebaseapp.com. So let me try this again. And instead, actually, how about this? Instead of doing it locally on one browser, I'll do it over the internet in a bunch of browsers. So here I've got Chrome, I've got Firefox, I've got an iOS simulator, and I've got Opera. Anyone still using Opera? Oh my gosh, there's like 4 of you. This is like the most I've ever seen. Well, you are not forgotten, my friends. Opera. Here we go. So let me try this again, and I'm going to say message. I can't believe so many people are using Opera. Now, before I hit enter and commit this change, just to again set what's going on, I've got all of these browsers that are at a public website on the internet. So if you went to your phone, if you went to, it's not worth it, but if you went to raccoon-house.firebaseapp.com, you would also see these updates. So I'll hit enter, and this is all happening over the internet, right? Nothing is happening in this room. Barely anything is happening in this room on my Wi-Fi. Hit enter, and then it all updates it instantly. And again, that's all with just these few lines of code. So that's pretty cool. In fact, I like to often joke that Firebase is more serverless than serverless because I didn't write any server-side code at all. That was all happening in the client, which is kind of where you want to spend your time, right? Your users are interacting with your user interface. You want to make sure you spend as much time as possible there so they have a nice interaction with your app. Yes, so here is all the server-side code I had to write to do that. No WebSockets, no long polling. It's all handled for you. So now I'm going to take a step to the side, I guess, and talk about what we traditionally think about as serverless, which is functions as a service. And in Google Cloud, we have something called Cloud Functions. And if you use it through Firebase, it's called Cloud Functions for Firebase. So this is sort of what you might normally think of as functions as a service. You can use them to make microservices. You can use them to glue cloud events together. Right now, it's only Node.js. If you want to get on our Python alpha, come see me afterwards, and I would love to get your feedback as we're getting ready to build that and to release that. So basically, these functions run whenever certain things happen into the cloud. So a file gets uploaded to cloud storage, an HTTP event comes in. Firebase has a ton of like app type events. So if you know Google Analytics for websites, there's a thing called Google Analytics for Firebase, which is the same idea but for your app. So you can track like how your users are going through your app, where they get stuck, where they complete some task, and you can associate cloud functions that will run whenever an event happens. So if a user gets to a certain part of your app, you can have a cloud function that runs automatically. Whenever your app crashes, heaven forbid, we have a thing called Firebase Crashalytics that you can have a function run in response to that as well. So now let's do a demo of Cloud Functions. I'm going to hop over here. So here's how you define a cloud function. This is an HTTP cloud function, and if you've, make this a little bit bigger. If you have written in Express.js before, this should look pretty familiar. You've got a request object, which contains everything that comes in from the user's request. So if this is a form post, it would have all the values from the form post. Query string, if it's a HTTP post with a JSON body, it will automatically parse that out. And here I'm including the Google Translation API package, which if you've used Google Translate, it's the exact same thing, but just as an API. You also notice there's no service account, there's no credentials or anything. By default, Cloud Functions is automatically authenticated to the other APIs in your Google Cloud project. So this makes it really nice to sort of deploy to staging, deploy to production, deploy to test, deploy to QA, and it automatically picks up the appropriate credentials for that environment without you accidentally putting in the wrong, let's say, service account JSON file. So a couple things I'm going to do. I'm going to read the query string, and if I give it an MSG, if I give it a message, use that. Otherwise, default to hello world. And if I give it a language code, use that. Otherwise, default to Spanish. And then I'm going to call the translation API. So this is what we imported up here with the message, the language, and then a callback. All right, and we're going to be good citizens. And if we get some kind of error, output that. If not, we're going to send the user our translation. Okay, so so gcloud, which is the command line tool for Google Cloud, gcloud functions deploy. And I called it hola world because it's Spanish instead of hello world. Get it? Aren't I clever? And then trigger HTTP. So let's see how our Wi-Fi does here. Oh, come on. Okay, so it probably shouldn't take 2 minutes, but in case it does, let's see, what else can I talk about it? Everything you write to the console is automatically picked up by Stackdriver logging, and you can search it, you can set filters, you can set alerts, so say anytime some pattern comes in, let me know. There's also a tool called Stackdriver Error Reporting, which automatically is looking through your error logs, and it'll sort of intelligently, using machine learning, it'll surface those to you. So if it sees some error that occurs a lot, or something that it thinks maybe is important, it'll surface that. And it's smart enough not to give you an alert every single time this error happens. It'll roll them up into, say, a daily or whatever report. And then monitoring, it automatically tracks how long your function runs and how much memory it uses, because that's how you pay for it. You can deploy it from the command line like I just did, hello world. If you are a monster and you want to code in the browser, you can do that. We have a little editor as well. So let's see if that deployed. All right, so it has given me a URL here somewhere. Let me grab this. And let's see, my message will be hello friends. And the language will be Spanish. And it should. Okay. And all I have to do is change the query string. We can make it French. We can make it Greek. I don't speak Greek. Is that right? Hello, friends? Okay. If you guys started laughing, then I would be in trouble. So cool. But yeah, so it's just as easy. So I just basically made a universal hello world translator in just a few lines of code. And what's cool is you can now take these. This is happening over HTTP. So you can just invoke this from whatever. It scales up, it scales down as necessary. But you can also tie it to certain events happening in the database. So I can have it watch my Firebase database and run this translation function. I've sort of pre-baked it, so I'm not going to redeploy this function, but just for purposes of demonstration. Let's try this. I have basically that same function, but watching message 2. So hello, friends and enemies of serverless. So let's run that, and you can see it updates it. But then immediately a Cloud Function kicks in and translates it. So I guess there's no translation for serverless in Greek. And I don't speak Greek, but maybe we can try translating it to a few other languages, like, say, Japanese, Spanish, Danish. Or I have another function, actually, that will then trigger off of that, and we can translate it to 30 different languages. So anyone speak Korean? It doesn't have, I guess serverless does not have a lot of translation in a lot of languages, which makes sense. But I just had this function that was just watching for changes in the database. And as soon as it saw that value written, a value was written, it automatically ran and did that translation. All right. We have a local emulator, so if you want to run and test your code on your machine. You can set breakpoints and step into it and kind of all the normal debugging stuff that we've gotten used to. And so that's sort of step one. And then step two, once you build an app on Firebase, and then using Cloud Functions, you can now step into the whole rest of the Google Cloud Platform. We've got a whole ton of machine learning type things you can do. Again, once you're in Cloud Functions, you're automatically authenticated to the rest of Google Cloud. So you can do things like big data, which we'll take a look at, machine learning, and then integrate with other applications using PubSub, which is our publisher-subscriber system that works over HTTP and gRPC. All right, so next, serverless for machine learning. I'm not going to get into all of these, but we have a bunch of these pre-trained APIs that do analysis. So translation that you just saw, vision for analyzing images, which I'll show a quick demo of, speech, which takes spoken word and turns it into text, and then the opposite, which is text-to-speech, which takes written text and says it out loud, like a robot. It can analyze video, and it can analyze images, or sorry, it can analyze video language. So I'm going to show you a demo of this app here in a second, but let's first walk through it. I built a Firebase app where I'm going to upload an image, say I have this adorable raccoon, into cloud storage. And then a cloud function will automatically trigger, because it's watching cloud storage, and so it will trigger your function automatically. And then it'll do a couple of things. It'll do label detection and landmark detection. So let's see exactly what that looks like. Oh, and then it'll write it back to the Firebase database to update in the client. So let's take a look. So once again, I have another super beautiful app that I've made using Angular and Angular Fire. So let's do a live photo. All right. Get a squad down here. Oh, that's awkward. Yeah, we're definitely using that one. Jeez. All right. So let's see what it has to say. Awkward is probably public relations. That's the only label. That's interesting. All right, we should hopefully, come on, asynchronous. Okay, so that was kind of a boring one. Usually it says something entertaining like man. I'm trying not to be offended that it didn't know I was a man that time. But also it does text reading. So it's actually looking at the banner in the background. And you can see Intersoft, International, Agile Actors. And it also gives you, I didn't really format the JSON here, but it gives you coordinates. So like where does it have Intersoft, where does it have Agile, et cetera, in the background. So that's pretty cool. So let's look at maybe another file. What is this? This is me taking a selfie. So it can do text. It can analyze the image. And so this is just a REST API, right? So you can call this from anywhere. So here's a better label. So sky, landmark, ancient history. We're going to pretend like we didn't see this. Scroll up, scroll up. Right. It's in beta, right? It's not. Oh shit. We got rid of it. Let me let me do that again, and hopefully we get a different result. All right. But what I want to show you is that it actually recognized the Parthenon in the background. So it's not using, and here's the latitude and longitude. So it's not using the EXIF image from the file itself. It's actually looking at the pixels, and it recognizes, oh, I know that's the Parthenon, even though it's kind of just the corner of it, right? Like it's not a typical, and like my big head is covering a bunch of it. It still is able to recognize it. So it has a latitude and longitude, so I could pull it up in the maps. And sure enough, that's where it is. And then also there's this ID here. I won't get into the demo, but that's a key into what we call the Google Knowledge Graph API. And the Knowledge Graph API is basically an API that Google exposes. We know a lot about things. So we know that the Parthenon, for example, is a piece of architecture. We know that it's a tourist attraction. We know kind of the history of it. And so with that key, you can make a call into the Knowledge Graph API and get more information. It'll oftentimes return a photo. It'll return a link to like the Wikipedia article. So kind of all this metadata about what has been found in the image. So that's pretty cool. And then also web annotations. So because Google crawls the web, we may actually have seen that image somewhere before. So if I upload an image that I downloaded from other website, calling to this Vision API will say, oh, we actually know where this exists. So for example, here's a car, we can call the Vision API on it, and it will say it is a Ford Anglia, so that's the make and model of this car. But more than that, the Vision API will also tell you that this particular car is in the Art Science Museum in Singapore. And that's because Google has crawled the Art Science Museum of Singapore's website, and we actually saw this image. And even if it's not the entire image, even if it's a cropped version of it, we still generally can match. And not only that, we can say this is actually related to Harry Potter, the literary series, because it knows where this image is found. It understands the context of the page that it found it on in the Art Science Museum of Singapore's website. And so you actually can find out a whole bunch of information about this image that you wouldn't necessarily have otherwise, because you have access to kind of the corpus of Google's web search data. It's also randomly useful for doing things like, you know, if you let users upload files and you make them check, yes, I own the rights, this is my image, yada, yada, yada. You also could just do a quick API call on the image they upload and see, hey, does the image they upload, does it exist somewhere else on the web? And if it does, then maybe you flag it that this might be an image that they don't have rights to. Maybe they just downloaded it from Wikipedia. It can also do redaction. So you can give it a photo, for example, of a driver's license or something with date of birth. And it will do it on text, but also an image. It will actually like block out the pixels so you can extract and redact sensitive information. All right, so that was some pre-trained model. So this is a Vision API. It's nice. It recognizes thousands and thousands of different things. But what about when you want to do custom machine learning for your business or your particular use case? Something that's not just generally available, generally useful. Excuse me. So we have kind of this scale of machine learning, where on one hand, we've got, this is a cat. On the other hand, we want to know, like, this particular cat is named Daisy. We want to be able to identify Daisy. Well, the Vision API doesn't know who Daisy is. It doesn't know who your cat is, or who your dog is, or your particular airplane part or wing. So it's just trained on sort of general things, right? So how do you train something to recognize images of your cat versus another cat? So for that, a few weeks ago, we released a tool called AutoML. So super, super cool. AutoML Vision is designed to be an easy way for you to train a machine learning system to recognize images that you have. And normally this requires a lot of machine learning code, and you need a data scientist and statisticians. But this is designed to be really easy to use. And the way that it works is you basically upload a bunch of labeled images into the system, and it learns automatically on its own. So you would upload a bunch of pictures of your dog named Rufus, and you'd label it, these are pictures of Rufus, these are pictures of Daisy, my cat, and it starts to recognize Daisy versus Rufus, or Daisy versus your other cat, kind of in the universe of things. And then once that's done, you can access it again with a REST API, and in fact, you can also do it in the same API call as the Vision API that we were just looking at. Oh yeah, I forgot about this. This is actually a very funny example. So there's a gentleman in Tokyo who wanted to know, I forget the name of the ramen chain, but there's a ramen chain that has like 30 or 60 different ramen stores in Tokyo. So it's a chain, so every place has the same menu, you order the same things, but he wanted to know if I trained using AutoML, could I train it so then when I took a picture of a particular bowl of ramen, it would tell me which of the 60 stores this came from. And again, bear in mind, it's a chain. It's the same food. It's the same bowls. And he did. And he actually was able to get 94% accuracy. Just by taking a picture of the bowl, it could tell you which store it came from. Yeah, it's super cool. So now we'll do a demo of this. So I have trained it on a bunch of types of, well, not a bunch, a few types of cheese. So if my internet cooperates. Okay, so here you can see the labels. I have, hopefully, I don't know if you can see that. I have brie, cheddar, goat cheese, Gouda, Parmesan, or no label. And if I mouse over it, you can see I've labeled this as Parmesan, goat. So these are known images. Like, I know what these are. And that's important because that's how you train your machine learning model. You say, I know this is this, I know this is this, I know this is this. And then once it's trained, then you give it things it does not know the answer to, and maybe you don't know the answer to. So just to kind of scroll down here, some of the sample images, cheddar, Gouda, goat cheese, label statistics, just to get an idea of how many images you need. So we generally recognize, you have to have a minimum of 10 images of a particular type. Best case, you have like 100. That's not always doable, but just to show you an example, here I've got 81 images of Gouda, 76 images of Brie. So let's show what just calling the Vision API. So here's the picture I took at the airport with some cheese in it. It's got actually some blue cheese, which is not part of the, I didn't train it on blue cheese, but over here it does have Brie. So let's see what, this is the Google Vision API with no custom training, right? So this is just generic Vision API. So let's see what it comes back with. Come on. It comes back with, it is 88% confident drink, food, meal, stemware, brunch. And these are all, this is all correct, this is all accurate, but in my particular use case, I want to know what kind of cheese am I eating? And the Vision API, it actually does know some kinds of cheese, but I want a system that just tells me definitively what kind of cheese this is. So now let's take the same image and let's put it into this thing that I have trained. So online prediction. So let me, I'm going to upload this cheese photo, and then let's see, where's my awkward? That's all awkward. What kind of cheese does it think I am? Because the way that this works is, with a custom model, it's going to guess some kind of cheese, right? All the percentages add up to 100. So I am not cheese, thankfully, but it's going to make a guess. So it'll be interesting to see. I actually have not done this, so it'll be curious what it does. So just something to be aware of, right? Like whatever you give it, it's going to give you its best guess. Come on. By the way, during the alpha period, there may be a warm-up delay with your model. If your initial request returned an error, please wait a few seconds before trying again. All right, I should have brought something to juggle. Well, while that's spinning, we're all familiar with the concept of cold starts in serverless, right? This is a really bad cold start. Okay, well, while that's spinning, if you want to sign up, it's in private alpha right now. If you want to sign up for CloudML, cloud.google.com/AutoML is the URL, or there's the blog post if you guys want to take a picture. All right, photobombing all of your notes. And still thinking. Good times. It's not usually this slow. And it's fine if your users have to wait 10 minutes, right? No, but that being said, so it is in private alpha. Oh, here we go. Oh, this ought to be interesting. What does it think this is? All right, 98% confident it's Brie, which is true. That's Brie right there. And this is an image I had never seen before. I don't know what kind of cheese it's going to think I am. Oh, it is very confident that I also am Brie. Turns out, it just always guesses Brie. This, out of context, 0.5% that I'm a goat is kind of what that looks like. Anyway, but you see, it will get, I guess I look more like Brie than anything else. All right, so, and then now once you want to get into really specific, customized, non-image type machine learning, we have an open source library called TensorFlow. So it's open source, it's on GitHub, it's super, super popular, tons and tons of tutorials, examples, sample data sets. It is getting easier. There's a little bit of complexity to it. It's pretty mathy still, but like I said, there's a lot of examples on how to get started, both on GitHub and people writing blogs. So check that out. And then sort of the serverless aspect of it, on Google Cloud, we have a tool called Cloud ML Engine, which will run your TensorFlow code serverlessly, scale it from 0. So if you have thousands and thousands of images to train on, it'll automatically scale up, do all the training, and then scale back down to 0. And it also does that when it does prediction. Hopefully a little bit faster than what we just saw from AutoML. So TensorFlow runs on CPUs, GPUs, and TPUs, which is the custom machine learning chip we have in Google Cloud. But it also can run on mobile devices. And the reason I bring this up is you can do things like train on a huge data set in the cloud. So gigabytes, terabytes, petabytes of data to train your model. And then it'll create this little prediction model that you can then put on your device. So your Raspberry Pi or your iPhone or your Android app can do machine learning prediction on device without having to call out to the cloud at all. So that's really, really cool, and it's something you see a lot of. Well, you can do prediction in the cloud, create an API, maybe some call it from the app itself, but you also can do it within the device as well. And then finally, we just have just a few minutes left, I'm going to talk about serverless for big data. Oh yeah, whoops, we're getting close. So I'm going to talk about another tool called Google BigQuery. So BigQuery came out of an internal project at Google called Dremel. So basically, Google has a lot of ads data, as you might think, like a lot of ads data, a lot. And so it was taking so long to run every day's, it was taking, let's say, a day and a half, 2 days to run the previous day's report, right? So as time goes on, the reports keep getting further and further behind. So some engineers are like, okay, we've got to figure out a better way to solve this problem. So they came up with a tool called Dremel, which we now expose as a tool for our customers to use called BigQuery. So it's a SQL database, and it can scale up to gigabytes, terabytes, and petabytes of data that'll execute in just minutes or seconds. So to be clear, this is an analytics database. You don't run your app in this database. You dump all of your data into this database, and then you run reports on it. Does that make sense? So for example, a select might take 1 second, which is really fast if you're selecting over 50 gigabytes. But if you're selecting over 1 kilobyte, that's horrible. So don't run your app on BigQuery. Put your data in it and do reporting. So let's do our final demo of the day. So one of the ways we have to show off the power of BigQuery is we have what we call public data sets. And these are just big data sets that we have copied into BigQuery. So we've taken it and copied it into BigQuery so people can play with it. So we have like history of Wikipedia edits. We have Reddit comments. And then my favorite is we have GitHub. So we've copied a whole bunch of GitHub into BigQuery. And by GitHub, I mean the actual code files themselves, like the actual text. So let me show you, for example. So I'm just going to do a select count. Again, it's just regular SQL. And see how many files. So this is about 2.3 billion files, just to give you a sense of what we're about to query. 2.3 billion files. Let me comment that out. And so let's do something a little bit more complicated than just a count. So what we're going to do is another count, but now we're actually going to do some string parsing. So we're going to actually look at the string value, and we're going to see if the rightmost characters equals package.json. We're going to assume it's a package.json file. So any Node developers here? Okay, what are we, Java? Fine. I've got something for you people too. JavaScript is the one true language. Just get on board. It's happening. Why does everybody always laugh when I say that? All right, so what I'm going to do, so this is just live on-the-fly string parsing. So there's no indices. I haven't set up anything. So let me go ahead and run this. And you'll see that. So how many package.json files are we tracking? Looks like 9.7 million JSON files. OK, I'm setting this up. And so it just went through 120 gigabytes of text, just like that, in 5.9 seconds. So no cache results, so there's no cheating, nothing up my sleeves, I'm not wearing sleeves. So we looked at the string values, did string parsing in all of those. And that's cool, and that normally would take quite a while in a traditional SQL database. But let's really up the ante. Let's see. Let's do some live JavaScript string parsing. So what we're going to do, I'm actually going to start this running. So I'm going to do a subselect here. So I'm going to look, again, I'm going to filter from 2.3 billion files, do some string matching to find, 9 million files. And I'm actually going to look in the text. These are big JSON files. I'm going to open up every single 9 million JSON files live, parse all the JSON into different objects. I'm going to walk the object tree, and I'm going to look for the dependencies key. This, if you don't know Node, this is how you put like library modules, packages into your application, is through a dependency key. So I'm going to see, basically what I'm doing here is I'm going to do a count of all of these and see what are the most popular Node.js packages in all of GitHub. So again, to think about what it's doing, is it's running through 9 million package.json files. So just a quick word. Traditionally, when you're dealing with a database, especially at this scale, you have to start thinking about things like inserts and locking, right? So if you have thousands of people doing reads and writes at the same time, you have to make sure you don't lock too aggressively, or you're going to have delays for some people. If you lock too frequently, your data might get out of sync. Indexing, you have to set up indices based on how you're going to query your data. Caching, and then query planning. These are all huge concerns when you're working with a database at scale. So what we decided in BigQuery is to just not do any of that, because that's a lot of work. So instead, we replaced all of this with the strategy of a hard drive. Well, actually, a lot of hard drives. Actually, a crap load of hard drives. Basically, we replicate your data across a bunch of storage. When you do your query, it spreads it out. It's like a map-reduce job, if you're familiar. And it churns through all of your data across all of these hard drives, doing the string parsing that we just talked about. And then your jobs all come back at the end and combine together to give you a result. So that's how BigQuery works. And that's why you don't have to do things like setting up indices or query planning or caching. And let's see. OK. So it finished. So it just went through 2.3 terabytes of string data. Again, it read it on the fly, no caching, nothing. It parsed all those 2.3 JSON files worth of JSON. I'm so excited. 2.3 terabytes of JSON data live on the fly and parsed it. And it's in 67 seconds. So of our Node developers, what do we think the most popular JSON package is in all of GitHub? Most popular NPM Node package in all of GitHub. All right, well, nobody cares. That's all right. I'll have a quick Java query to show you. So here you can see that 91,000 use Lodash, 91,000 use Express, debug, and so on. All right, so let's do a quick Java one. I'm going to see, what is this query? I'm going to do a similar thing, but for Java, where I'm basically looking through, so I'm doing a regular expression, yada, yada. I won't bore you. This one's a little bit faster. Oh, it's cached. Well, that was cheating. Let's try that again. And it doesn't take 67 seconds, I don't think. There you go. And it's a lot fewer files. So it's only 24 gigs, and it took 3.5 seconds. And it was doing regular expressions. Java.util, not surprisingly, the most popular one. All right, so that's just a demonstration of BigQuery. I'm not going to talk through this. cloud.google.com/serverless has a bunch of use cases for some of the serverless tools we have on Google Cloud. And here is the page you can take another picture of if you want. That's me on Twitter, @BretMCG. Everything I talked about today has a free tier, and most of them are quite generous. So you can get started, check it out, see if it'll be a good fit for you. Cloud Functions, for example, 2 million invocations a month for free. BigQuery, you can query 1 terabyte of data a month for free. Firebase has like a very generous free tier as well. So with that, that is all I have. Thank you very much.
Thank you. Thank you, Bret. Fantastic talk. All right. Questions for Bret? Here we go.
Hello. How easy is it to integrate Google Authentication in a mobile application developed using Firebase?
I missed the first part. You said how easy is it to build
To integrate Google Authentication.
Google Authentication. So the way that you integrate Google Authentication into Firebase is not much more complicated than going to Authentication, set up sign-in method, and then turn on Google. Now you have to also put some code in your app, but actually I think I have it in this. It'd be ugly to look at, but it's about 10 lines of code you put into your app. And so it just has all the hooks. But also you saw in there was Twitter, there's Facebook, there's GitHub. If you have your own authentication that already exists, you can write a provider to hook in that way as well. And you can have people sign in with multiple accounts and like combine them into the same sort of master account, if that makes sense. Does that answer your question? Any other questions?
Any more questions?
Oh, we have one up here.
If in the picture with the cheese, with the two kinds of cheese, there were two kinds of cheese that you had in your knowledge base, would it recognize both kinds of cheese? Like if you had Parmesan and cheddar?
So the question was, I happened to have two types of cheese in my photo. I had a blue cheese and I had a brie. If I had trained it on blue cheese, would it have recognized blue cheese and brie? So
yes, that's the question.
So probably it gives you a set of values and a confidence level. So it probably would say roughly like I'm like 40% sure it's blue cheese and 40% sure it's brie. So it's not really designed to do multiple labels. It's designed to basically give you one deterministic answer. In that case, because they were kind of equally weighted in the picture, my guess, I don't know, machine learning is voodoo. My guess is that it would probably give you a roughly similar percentage, but it's not really designed to do multiple labels like that. It's designed to give you like one thing. And sometimes by happenstance, you also get other labels that are useful as well.
So I also think that it recognized the Parthenon as the brie, not you.
It recognized what?
The Parthenon behind you, the Acropolis. It recognized the Parthenon as brie because it had the same color.
Right. So realistically, it probably recognized the Parthenon as brie because of the coloration. Yeah.
So while in Greece, I hope you get the chance to try a lot more of our cheeses. You know, it's not only feta cheese. We have a lot of cheeses you should try, and one of them is not brie.
I'm gonna have to go in
Any more questions before we let Bret go try Greek cheese? Yes.
Hi, thank you for your presentation. It's maybe not fair question, but behind the scene, isn't it server? So Firebase and everything, and don't you use WebSockets to send all the information to the different browsers?
So your question is behind the scenes, sort of what is Firebase doing?
Yeah, because we are talking about serverless.
Yeah, so Firebase is running servers in the backend. It's doing web service. It is, on the client side, it's detecting, can I do WebSockets? Does your browser support it? And if not, it falls back to like long polling. In the case of mobile, like whatever's appropriate, or whatever the WebSocket equivalent is for your platform, it wraps that as well. So yeah, it is using WebSockets, at least on the web side, behind the scenes. You just don't have to worry about it.
Yeah.
And then the other thing it does I didn't mention is also has offline support. So if you lose connectivity, either on your app, well, generally in your app, but a little bit also on your web, the local Firebase SDK will basically queue up your writes. So then when you get connectivity, it will push those all to the server, and any changes that have happened in the meantime, it'll sync those back down. So it's kind of using some local storage to do that.
Thank you.
Right.
I think we can take one more if there is one.
Any more?
Yes. Good. Here we go.
Hello, thank you for your presentation. I guess that what happened is that you wrote some HTML and TypeScript and you deployed that on the Google infrastructure. Is that correct? And importing some packages, you are allowed to use some function as a service stuff, but runs on the same infrastructure as well. But in realistic use cases, you're going to need something that is specific to your application, some REST API that works with the domain model of your application in order to make something meaningful. Would that REST API have to be built, be deployed on the same infrastructure as well, or is there a sensible mechanism to wrap calls to your own API within those TypeScript, HTML files that you are deploying to the Google infrastructure?
Yeah. So let me just maybe to rephrase, make sure that I'm answering the right question. So a lot of the functions I saw now are just sort of reacting to certain events in the cloud. What if you actually wanted to create a proper API that modeled your domain and you wanted to have your devices talk to it?
And I saw some sensible use case, by translating stuff. And I thought it would be very nice if I could use the translation infrastructure of Google, because it would be too expensive to build my own. And I would like the messages, maybe I would like to record the messages on my own database or on my own application infrastructure, and then maybe store the translation as well. How easy is it to...
I don't know if this answers your question exactly. Let's see, everything that I showed today is available just as a REST API. So if you have a mobile application, if you're running in your infrastructure, you can talk to Firebase from it, you can talk to the translation API from it. That's all REST APIs. So you can kind of pull out whatever piece you want and just inject it into your application. So in the case of the translation API, we have an SDK. So if you're running on C Sharp or Java or whatever, it kind of wraps the API for you nicely, but at the end of the day, it's just a REST API. Even the database is a REST API, BigQuery is a REST API, or has access to it. Does that kind of answer your question? Yeah.
Yes, it does. Thank you very much.
All right.
Thank you very, very much. Thank you for that
Thank
great
you.
presentation, guys.